Okay, today we'll start with the new model. That's the second model. That's to be graphic processing unit. Okay, graphic processing unit. Okay, today we'll discuss the graphic processing units. These are the units like CPUs. They are also will be having the different programming techniques here. Programming techniques. Model 2. In this model 2 we have the GPU. Okay, GPU is nothing but the graphic processing unit. Okay, graphic processing unit. Okay, graphical processing units. This is the graphical processing units. Graphical processing units. Okay, graphical processing units are they are not a web applications. These are the standalone processors. Okay, these are the standalone applications, and also they don't run on the different OSs. Okay, some scenarios. Okay, they don't ordinarily run on the some OSs like operating systems such as the direct access of the standing storages like that, and also they don't run on the directly on the operating systems services, and also programming in CPU also involves the writing the code on the CPU host. Okay, it will run the if you write the code on the CPU, that will be and also even the GPU memory is also you use the separate code for that one. CPU code and GPU code are different. Okay, GPU code is something. Okay, GPUs consist of what here, the thousands of thousands or hundreds of cores here. Okay, the cores. Okay, which will enhance the what is the it will enhance the processing of that particular application, processing of that particular program here. It will enhance. Okay, graphic cards. So as we already seen in the NVIDIA graphic cards and all, those are all what here the graphic GPU units only. The GPU units are in the usually the used in the parallel computing for reference of the in order to refer the using the graphic processing units to execute the many computational tasks simultaneously. Many computational tasks you can execute here. Many computational we can we can execute simultaneously. We can execute many computational tasks we can execute simultaneously, and also we have the CPU contains the GPU contains the thousands of smaller cores and designed for the parallel computing purpose. Okay, GPUs. Okay, the graphical processing units are also used for the parallel processing purpose, and also this enables the used in the handle the large scale data. Okay, these are all used for the handle the large scale large scale data, cross scale data, and also to ensure that executing of the multiple operations concurrently. Okay, and also we can execute the multiple operations concurrently. Okay, simultaneously is nothing but the it's nothing but the concurrently only. Concurrently we can execute the number of okay number of programs. Okay, number of tasks which has to be simultaneously we can execute. Okay, even the key concepts for the parallel processing are the we can have the parallel processing is nothing but the GPU will divides the number of tasks. What is to do the any task, if any large task is there, that is to be divided into number of tasks. Okay, if my if the task if the any problem, okay, if any work is there, that is to be divided into number of tasks. Okay, number of tasks. Okay, number of tasks. Okay, this is like a SIMD. Okay, this is like a SIMD, it's working, but here the SIMD is we are not using any programs here. The the graphical processing units itself having the some programs that is to be divided the that any if you have any work that is to be divided into number of tasks. Okay, this will be enhanced the okay one by one. Okay, these tasks are divided, then these tasks has to be executed one by one simultaneously, so that we can speed up the execution of the instruction. We can speed up the execution of these tasks. Okay, we can speed up the execution of these tasks. And also we have the okay in the architecture. If we go for the architecture way, the CPU and GPU. Okay, CPU and GPU. Okay, CPU can have the few cores here. Okay, we can have the few cores. Okay, GPU is nothing but the graphical processing units can have the hundreds or thousands of cores. Okay, thousands of cores are nothing but the process which will hold. Okay, even these thousands or hundreds or thousands of cores can simultaneously they can handle the number of tasks here. CPU consists of only few cores, but the GPU graphical processing units can have the hundreds or thousands of cores here, hundreds or thousands of cores here. And also GPU. Okay, okay, programming models. If you go for with the programming model side, okay, programming model side. If you go with the GPU with the programming model, the GPU will use what here the API. What is that's nothing but one of the API that is to be what here the CUDA. Okay, that's nothing but the CUDA. CUDA is nothing but the compute compute unified 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 device device architecture. Okay, one of the API that is to be used by the GPU, that's nothing but the CUDA's API. Okay, CUDA is what here the one of the API which will have the which is named as the Compute Unified Device Architecture. CUD is nothing but the Compute Unified Device Architecture. Okay, this can provide this can provide the programmer with the that is to be what here the runtime environment it will provide, and even it will provide what here the compiler, and even it will provide the libraries. And also we can also run them simultaneously. Because of this one we can write the any number of codes with the help of the this CUDA API. If you want to if you want to write the programs related to the graphical processing units, then we have the one of the API that is nothing but the CUDA API. CUDA API is nothing but CUDA API. CUDA API provides what here the runtime environment it will provide, even compiler it will provide, and also libraries whatever we want. Programmer can write the programs easily with the help of the libraries. Libraries consist of the number of interfaces and the some functions also, and also we can get the some blueprint idea about the programming knowledge. Okay, that's nothing but here the it's one of the API we are using here the graphical processing. Okay, parallel computing in the distributed memory programming side, there we are using the message MPI and the open MPI are the two APIs we are using there. But in the graphical processing units, we will be using the one of the API that is called as the CUDA. CUDA is the one of the API which will provide the runtime environment, libraries, and also which will provide what here the compiler also. By using these techniques, API with the user programmer can write the codes for the related to the what graphical processing units. Okay, that's nothing but the CUDA GPU. Okay, these are the some basics about the GPU. How the GPU is considered? GPU mainly consists of the, I'll repeat here, just look at here. GPU consists of mainly what thousands of cores. Andre hundreds are more than CPU can consist of the few cores ಅಥವಾ few processors ಅಷ್ಟೇ ಇರ್ತವೆ CPU ಒಳಗೆ. But in the GPU consists of the thousands of hundred or thousands of the processors here. Okay, many computational tasks we can compute, okay, simultaneously and even concurrently. Okay, we can do it. Okay, these are the graphic processor units are mainly used in the machine learning. Okay, machine learning ಅಲ್ಲಿ graphic processing units use ಮಾಡ್ತೀವಿ. Even we'll be using the AI technology. AI is with the artificial intelligence technology. There also we will be using the there also will be using the deep learning. Also there also you will be using the GPU, and also you will be using the high performance computing HPC, and also data mining finance. Okay, in such a large scale data also we can also solve here. Okay, the if you have the large scale data, if you have the any task which is to be very large, that is to be divided into what how many tasks, number of tasks. Okay, now if I divide the number of tasks, then we can execute the particular program, that is to be speed will be increases because of the concurrently we are running one by one task here. Concurrently we are running the or concurrently we are running or what here the execute the programs which are to be concurrently, because of while using the concurrently we can increase the speed also. Okay, as I already told you, in the architecture base CPU mainly consists of the only few cores, but the GPU consists of what hundred or thousands of processors in its unit. Okay, in the programming side, okay, programming model will use the one of the API, that is nothing but the CUDA is nothing but the compute unified device architecture. Okay, this is the one of the API which will help to the programmer to write to the programs which this will provide what type of what type of environment, runtime environment. Even it will provide the compiler. Even it will provide some libraries which is to be useful for writing the programmer to write a program. Okay, that's not. This is all about the GPU. For these are all the some basics of the basic GPU. Okay, okay. GPU is mainly parallel execution. Okay, parallel execution. Usually the GPUs are developers will write the codes usually in the popular languages like C, C++, even Python also. But CUDA extensions expresses parallelism based on what here the C programming only. C programming. Okay. Even CUDA environment which will provide the Python programming and even the C language. But the more and more applications will be using the this CUDA API, which will be useful for the writing the C and C++ code only. And also we have the this code can be instruct the GPU perform the many calculations concurrently process known as the general purpose. Okay, we will be doing what here the some calculations here which is to be concurrently we will be running here. Okay, some task here whatever we have, the task will be divided into number of tasks here. If any problem is a large scale problem, that is to be divided into number of tasks. Okay, this number of tasks will be run. Okay, this will be run one by one, not okay, they will be run simultaneously and even concurrently. Okay, this will be we call such an environment, this such a process we call as what here the general purpose computing on. Okay, general purpose computing on GPU, 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 general purpose computing on graphical processing units. GPU, GPU is nothing but the general purpose computing on graphical processing units. Okay, graphical processing units. Okay, the CUDA. Okay, the CUDA software is useful for the collaborations. Okay, sometimes okay, collaborating of the some CPU which will handle the CPU will handle the some okay, okay, this is the collaboration. Okay, this is the completely CPU will handle what here the only the sequential. CPU will handle the sequential parts. Okay, sequential parts of the workload. And this one the GPU will handle what here the this is to be computational iterative. Okay, that's to be computationally intensive parts. Okay, computationally. Okay, CPU will handle the only the sequential parts of that particular problem, but the computationally which are to be very intensive, which is to be very tough to the tough to the programmer, that is to be handled by whom? Here the GPU. Okay, GPU ಏನು ಮಾಡ್ತಾ graphical processing unit ಏನು ಮಾಡ್ತಾ which will speed up your programming. As you all seen gaming program ಇರ್ತಾವೆಲ್ಲ games ಇರ್ತಾವೆ, that is to be speed of the game will be increased by whom? Graphic processing unit ಮೇಲೆ ನೀವು GPU ನಿಂದ ಆಗ್ತಾವೆ, graphic card ಹಾಕ್ತಿರಲ್ಲ. So the similarly the graphic processing units, okay, this to be used only to the computationally intensive part. Okay, this is to be used for the running of the computer, solve the running of the handling of the computationally intensive part. CPU will handle only the sequential parts. GPU will handle the which is the part of the program which is to be computationally intensive. Okay, very computationally intensive part. Okay, very computationally intensive part. Okay, this one we call is what here the this one calls the type of we call as the GPGP is nothing but the general purpose graphic processing units. Okay, some applications related to the GPU are what here the GPU is mainly used for the artificial intelligence, machine learning, and also will be using in this one is the scientific computations. Okay, scientific calculations, because scientific calculation will have the intensive computational parts. Okay, intensive computational parts will be handled by whom? GPU, graphic processing units. That's what they will be using the scientific computing, and also we will be using the high performance computing HPC. There also will be using, and also will be using this type of GPU data mining and the finances. Okay, data mining. Okay, database data mining. Okay, data mining is one of the concept which will be used by the programmer to handle the some data. Okay, okay, artificial intelligence and deep learning and scientific computing, high performance and data mining side will be using the graphic processing units. Okay, this is all about the graphic processing units basics. Okay, this is all not in your syllabus, but they will be asking for the graphic processing unit. If they ask to write a note on the graphic processing unit, there you should have to answer these things. Okay, graphical processing units will have the hundred of or thousands of cores inside, and also this is not a standalone processor. This will consider standalone process. They don't run on the particularly only the OSs which will be having the services. Okay, services. ಓಕೆ ಸರ್ವಿಸ್ ಬೇಸ್ ಕಂಪ್ನಿ ಇರ್ತಾವೆ, ಕೆಲವೊಂದು ಇರ್ತಾವೆ ನೋಡು. ಈಗ ಸರ್ವಿಸ್ ಅಂತಂದ್ರೆ ಏನು? ಯುವರ್ ವೆಬ್ಸೈಟ್. ಓಕೆ, ಯುವರ್ ವೆಬ್ಸೈಟ್ ಈಸ್ ವಾಟ್ ಯುವರ್ ದ ಸರ್ವಿಸ್ ಟು ದ ಪೀಪಲ್. ಓಕೆ, ಯುವರ್ ವೆಬ್ಸೈಟ್. ಈಗ ಕೆಲವೊಂದು ಅಮೆಜಾನ್ ಕಂಪ್ನಿ ಇದೆ, ಅಮೆಜಾನ್ ವೆಬ್ಸೈಟ್ ಇದೆ, ಅದರಲ್ಲಿ ಏನಿದೆ? ದಟ್ ಇಸ್ ಟು ಬಿ ವಾಟ್ ಯುವರ್ ದ ಸರ್ವಿಸ್ ವಿಚ್ ವಿಲ್ ಗಿವಿಂಗ್ ಟು ದ ಸರ್ವಿಸ್ ಟು ದ ಯೂಸರ್. ಓಕೆ, ದೇರ್ ವಿಲ್ ನಾಟ್ ಯೂಸ್ ದ graphic processing unit. There will be not using graphic processing unit. Just processing graphic processing units are used in the computational tasks. Okay, which will be used when the scientific calculation iddalli those in the field will be using. Sometimes we call as the graphic processing units will having the programming as what a heterogeneous programming, because we will be having the different programming side as OpenMP, and also we will be using the MPI, that's nothing but the message passing interfaces. I'll be using combinedly. We will be using that one. We call as the heterogeneous, and also we will have the some hybrid technologies also will be using. Okay, this is all about the second model. Okay, this is all about the second model. Whatever I taught it till now, this is also a brief introduction about the second model. Now we will consider the one by one in the in this module. As the first one is what here the GPU programming. Okay, first one is what here the GPU programming. Take the notes, some notes here. GPU programming. First, take the headline as the GPU programming. Okay, graphical while using the some APIs here. What here the CUDA API. Okay. Key applications of the GPU are, okay, next. Okay, only 2 lines. Key applications of the GPU are First one is the artificial intelligence and deep learning. Artificial intelligence and deep learning. Key applications of GPU are: first one is artificial intelligence and deep learning. Second one is scientific computing. Scientific computing. Third one is what? High performance computing. Third one is high performance computing. Fourth one is data mining and the finance. Fourth one is what? Here the data mining and the finance. Hmm? Data mining and the finance and finance. Okay, usually the threads which are running on the processors, okay, are typically divided into two groups. Okay, two groups, the threads which are running on the which of the group is using the SPMD. SPMD is SIMD, sorry, SIMD, single instruction multiple data type of threads they are using. And also will be using the SIMD groups is not even the run on the lag step, okay, because of the some unuseful programming methods you are using. Okay, threads in the groups are executing the different, okay, some of the threads which will be used idle, okay, which are used to be idle one. Okay, idle one. Okay, let me write something here, then only you can understand. Hmm? Okay, okay, threads, okay, the whatever they are using the threads which are can be divided into two groups here. Two groups. One group is what here, the SIMD. SIMD, okay, SIMD is nothing but the single instruction multiple data. Okay, SIMD is nothing but the single instruction multiple data. The threads which within the group use the SIMD model, and the two threads different groups are run in the independently. They will run the independently because of the single instruction. We can run the multiple data. That's nothing but the, we can run the number of two threads can run simultaneously. And also we have the threads which are to be used in the SIMD group may not run on the lag step. Okay, this runs will run not run the lag step. Log step. Okay, lock stop. Okay, if I use the lock step, the threads which is to be idle one. Okay, if you want to run some program, some threads will be idle one until the execution of the other thread. So in order to go in such a situation, some threads will be not run. Okay, those to be kept what here, the idle condition. Idle condition that is to be done with what here, the lock step. Okay, lock step. If I use the lock step, the task, okay, the threads which are to be which will be not at all running, those can be kept as the idle one. Idle one, those to be kept on the idle one. So that's the nothing but the, we are using the idle some threads. Okay, idle some threads. Okay, given name as the idle threads only. For example, if I have the, suppose I have the 32 threads, Suppose I have the how many threads here? The 32 threads, 32 threads, and each threads in the SIMD group, and each thread has the private variable. Each thread having the what here? The private variable. Private variable as the what here? The my okay my x, okay my x, and also which can be private variable as the rank, rank gp, rank gp, sorry, rank in gp, sorry, rank in gp, and also which will be ranging from, okay, now the, okay, the ranging, we having how many threads here? 32 threads, which will be ranged from what here? The 0 to 31, 0 to 31, and also we suppose we have the threads to be executed as with the some pseudo code here, okay, int, int rank in gp, rank in gp with the my x, my x, okay, I'll be running the some codes here, the if rank in gp, rank in gp which will be less than the 16, less than the 16, my x equals to my x plus or equal to 1, else my x equals to is my equal is negative or equal to 1, okay, okay, just to copy this pseudo code, okay, just to copy that pseudo code. Suppose I have the, there are 32 threads are there in the SIMD group, and even the thread has the private variable that is to be named rank in GP. Okay, rank in GP. That will be ranges from what here the 0 to 31. Okay, that can have the 0 to 31. Also suppose that the threads are executing the following code. What will be the first one? Okay, int my rank is there, okay, rank in gp with the variable as the my x, okay, okay, next is what here? The rank in gp with the less than the 16, then it would be what here? The my x equals, my x is plus or minus plus equal to 1, okay, else the my x equals to less equal to is the minus, negative, plus or 1, okay, if the my rank is less than the 16 number of okay, rank is 16 number, then the execute the fast assignment, okay, how many variables are here? 32, 32, okay, 32 here, 32 is divided by 2 is how much? 16. If the my rank is less than the 16, then the fast execution will be happening here. If the rank is more than or equal to 16, then the idle one, okay, the remaining part will be idle one, okay, remaining part will be idle one. There's nothing but here the we are dividing the given number of threads into two parts here. One is what here? The first part 0 to 15, that is the less than the 16 one, and also 16 to 31, that is to be more than the more than or equal to 16. The part which is to be belongs to what here? The 0 to 15, that is to be running. If I consider that particular part of the threads, then the particular that those particular number of threads task will be run very fast manner, very fast manner. If I consider to be less than other part, that's to be my rank, okay, my another rank in gp equals to is the equal to more than or equal to 16, 16 kita ಮೇಲೆ ಇದ್ರೆ 16 to 31 ಇದ್ರೆ that is to be part to be considered as what? Idle part, okay, that is to be idle part, okay, we can roll, though even the roles can be interchanged here, okay, even roles can be interchanged if the, okay, threads with the rank with less than the 16, that is to be run when the will be execute, yeah, will execute, okay, if the rank is more than or equals to 16 will not execute. That is to be kept as what here the idle one. Okay, the here we can also reverse here. We can also interchange here. We can also interchange one. Okay, even the I can also write it's what here the rank is less than the 16 will be idle, and rank is more than or equals to 16 will execute. It means here the I can also reverse the operation here. I can even consider the more than the 0 to 16 0 to equal to 0 to 16 less than the 16, that is to be considered as the idle part. Now the more than the equal my rank GP equals to equal to 16 or more than 16, that is to be considered as the exit part. Even I can also interchange, even I can also reverse. Okay, this is to, of course we are doing what here the threads to be instructions which are very efficiently, we can also reverse this one. Okay, this is the main the SIMD one. Okay, we are doing the SIMD. Okay, the single instruction, multiple thread, multiple data, but here the results, whatever the parts of considering the part of the programming can be reversed from the idle to the execution, I1 execution to the idle one. Okay, this is all about the GPU. Another issue with the GPU programming is that can be scheduled to execute the program. We can also schedule the part of the program to be execute scheduled parts. Okay, we can give the some schedule to the particular part of the program can run the after the particular period of time. We can also schedule this one. Okay, we even the hardware scheduler is are more used here, and also we will getting the little overhead technique also, overhead. Okay, this is what here the scheduler will be using here, hardware scheduler, and also overhead concept is there. Why the what is the overhead is nothing but here the little overhead is be getting because of the we are scheduling the some tasks, some threads to be executed particular period of time, that is to be overhead to the CPU, GPU, and also you will be using the all the threads in the SIMD groups uh, run in the different environment, but in the SIMD groups are ready to run in any time, but with the particular period of scheduled time here. If the any part of the programming, okay, that some threads are ready to execute, remaining parts of the threads are to be waiting. That waiting lock, waiting, okay, that waiting of that particular thread is to be kept here. You have some particular period of threads are ready to execute. ಆ ಒಂದು number of threads execute ಆಗಬೇಕಾದ್ರೆ remaining threads has to be waiting, should be kept in the idle or waiting condition, Okay, this is all about the graphical processing units. Tomorrow we'll continue the programming hybrid systems. Okay, programming hybrid system. I will give the some brief. Okay, hybrids are used nothing but they will use the only one API used here. Which one API? CUDA, API we are using. But in the hybrid GPUs are here the will be using the different APIs like MPI, message passing in interface, and also OpenMP is there. Another one is that what is that? Even the CUDA also will be using with the hybrid, with the combination, with the different combination of these APIs. Okay, that's nothing but the programming in the hybrid systems. And also we have the input output concepts with the memory and the SIMD also. The same concepts are using, but with the some additional programming will be adding here related to the graphical processing. There we have studied in the SIMD and MEMD with the hardware and the programming. But you will be studying the SIMD and the MEMD particularly to the graphical processing units. Okay, graphical processing units related now SIMD, MEMD ಓದಬೇಕು. But in the earlier model, first model, there you have seen the SIMD and MEMD with the hardwares and also programming side. But in this second model, we will be concentrating on the SIMD and MEMD with the graphical processing units with the programming side. Okay, done?